Go watch your pond. We talk about that a lot, right? Go out to your pond, go out to your stream and see what you see. A lot of these invertebrates you might not see. They might not be active all the time. But get a net, collect some leaves and see if there's, something crawling around in there. It'd be a good indication to kind of look at your pond and see what kind of activity you might have.
Welcome to Fins, Fur, and Feathers, the Fish and Wildlife Management podcast at K-State Research and Extension. I'm Dr. Drew Ricketts.
And I'm Dr. Joe Gherkin. We're both lifelong hunters and anglers and K-State Research and Extension specialists who help citizens with their fish, wildlife, and pond management needs. If you've ever had a wildlife or pond management challenge, then this is the podcast for you.
We address common fish and wildlife management problems using a scientific approach to provide proven and practical solutions to the issues that you may be facing. Welcome back to Fins, Fur, and Feathers. This week we've got an aquatics episode. Joe, are you going to talk about something that gets wet?
I am, yes. We're going to talk about bugs today. I'm getting ready to go to a conference where we're going to spend a lot of time talking about bugs. But, invertebrates, I get in trouble for calling them bugs for my wife all the time. So invertebrates, which we'll refer to as bugs for most of this talk here, are important components of aquatic systems. So I thought we'd spend a little time chatting about them today.
Sure. Well, I know not all invertebrates are bugs. So what makes an invertebrate, I guess?
Yeah, that's true. They're not all bugs. There's lots of different varieties. So an invertebrate just is an animal without a backbone, right? And so when we think about that, a lot of times we're thinking about, what we would call bugs, but that's not always the classification. And so there are two main groups. Microinvertebrates are small animals. So they can be single-celled. They can be up to multi-celled little plankton is how we would refer to them a lot of time, but they're going to be small enough that you're going to have a microscope to see them. They can be really important. They feed a lot of fish, a lot of really big fish. Some of the biggest whales in the ocean, for example, feed entirely on these tiny little animals. So they can be really important. They're the base of the food web in a lot of systems, but they're really hard to see, and they're kind of their own little class. Today we're going to focus on what's called macroinvertebrates. And macroinvertebrates are invertebrates that are big enough to see without a microscope. So you can pick them up. They still might be really small, but you can see them with your eyes. And so lots of different groups. Even there, we can talk about invertebrates that look like or act like bugs, for example. But if we think about a clam or a freshwater mussel, those would be invertebrates. A crayfish is a freshwater invertebrate. So lots of different groups of invertebrates. Today, we're going to focus primarily on those macroinvertebrates in aquatic settings.
Very cool. Well, I know I like macroinvertebrates. When I was a kid, every time it rained, I'd go macroinvertebrate hunting in the ditches there in the little town I grew up in. So I'd go looking for those crawdads in the ditch and catch a whole mess of them and think that I was going to have a crawfish boil or something like that. And sometimes they got used for fishing bait, but we never did eat any of those.
Yeah, if you're going to eat them, you want to make sure you let them clear out for a few days. But most of the ones we want to eat, it's better if we just let those get raised and leave the ditch ones maybe to feed into fish.
Sure. So, you mentioned that there's a lot of different kinds of invertebrates, but, really if we get down to the nitty-gritty, how many kinds are there?
Yeah, so in science, we use taxonomy to kind of group different animals, and one of the taxonomic groups is an order, and an order is kind of saying, hey, there's a big group here that all kind of have some similarity, and there's 10 different orders. If we break it down, there's about 70,000 different aquatic invertebrates that have been described. And so that is a really large number, but that's estimated to only be about 10-20% of all the aquatic invertebrates, freshwater invertebrates that are out there. And that might even be, too high of a number. There's a lot of invertebrates out there that just have the incredible diversity, and we haven't had the chance to identify them all yet, especially if we start thinking about, remote areas that these animals might be at. So lots of different groups there, but there's really four main groups if we break them down. So there's a ton of different animals, but if we break them down, there's four main groups. And those I'm going to describe them based on their functional feeding group. That's one of the ways that we describe these different invertebrates. So there's four main groups. The first group are called grazers. And so these grazers kind of slide along. They have like a raspy mouth a lot of times, kind of like sandpaper if you think about it. And they kind of scrape surfaces. So they might scrape a rock, for example, that has algae growing on it and clean it off. In an aquarium, we might think about a snail, right? If you watch a snail, if you've ever had one in an aquarium, you can kind of watch it go back and forth, and it's just kind of like a vacuum cleaner cleaning that algae off the side of the tank. Well, that's how they feed in nature too. They're walking along, scraping that algae or the biofilm, or might be some detritus on that surface. They're scraping it off and eating it. So those grazers are fairly common. Ephemeropterans and snails are the biggest group there.
Ephemeropterans. What's an ephemeropteran?
Ephemeropter is an order of mayflies, and so they're just a group of invertebrates that we would see typically emerge early in the season, but they're going to be a really important group for indicating water quality and things like that. So ephemeropterous snails are a big grazing group that's out there.
Very cool. Very cool. So, I mean, that's, if we think about terrestrial systems, grazers or herbivores in general, that's a big chunk of the critters that are out there. And, of course, those are the critters that I really care about because they're good at turning plants into meat, and meat's my favorite thing to eat. So I appreciate the fact that they do that.
Yeah. They're really important. They're out there grazing. Another really cool group are called collector-gatherers, and these are really cool because they're collecting stuff that might be kind of washing through the system. If we think about a system where water is running, a stream, a creek, a river, something like that, there's a lot of suspended particles, and these groups, can go out and they make little nets, a lot of them. And it's going to filter that water just like a net that we would put in the water. And they're going to collect a bunch of little detritus, biofilm, little pieces of particles. And then they go out on their net and they kind of do that same thing. They graze back and forth on that net, but they're collecting particles that are drifting. And so that process, they can collect their food that way. Similar type of food content that they're eating as the grazers, but instead of actively knocking it off of the surface, they're waiting for it to drift into the water itself, right?
Very cool. So kind of the pack rats of the aquatic invertebrate world.
All has to come back to a terrestrial system for you.
It does for me, yeah. I've got a pretty small mind, so I have to have analogies for everything.
Well, that's good. I think that helps connect it, The last group, not the last group, but the next group would be shredders. And so these are really important. Another big word is allochthonous inputs. So allochthonous means it's outside of the water itself. So if we think about leaves in the fall, falling into a stream or a pond, they have to break down somehow. And one of the ways that they do that is by getting torn up into little pieces or cut into little pieces. Think about taking a pair of scissors and cutting a leaf into, 1,000 different pieces. That's a lot of what these shredders do. And so arthropods, crayfish are a good example of that, where they'll go out and they'll cut up a lot of little leaves or input that's coming from outside the system. And that's really important because as they break that down, that increases the surface area for bacteria to get on that leaf or whatever the material is. And it allows that process of breaking down that organic material to kind of, move at a faster pace, a pace that, over seasons, we're not getting too much input in the system, for example. We can start to break it down. So the shredders are important. I think the last group always surprises people. When we're talking about invertebrates, there's a whole group out there that are predators. And so they'll sit there. A lot of them have forelegs that can help grab onto animals. They have mouth parts that can pierce into animals. And so a dragonfly larvae, for example, can grab onto a little fish, and it can grab onto it with its legs, and it can pinch it on the sides and immobilize that fish and eat the fish. And so when we start talking about an invertebrate eating a fish, or what we would call a water bug eating a fish, that just surprises a lot of people. And it really surprises you if you're out with a net, you just collected a bunch of fish and you reach down to figure out what that little bug walking around is, and then it bites you. So it wakes you up a little bit. But just always exciting and surprising that those types of animals are out there.
Yeah, I think that's very cool. And one of the neat things I think is, when you're collecting all this stuff, is thinking about what it turns into when it's no longer an aquatic invertebrate, because that's oftentimes a larval stage or some precursor to the adult that's gonna come out, like the mayfly or the dragonfly and those sorts of critters.
Yeah, a lot of this talk came from thinking back to when I was a kid, and I remember spending hours. Now you just Google it, but when we were kids, you couldn't always do that. I would spend hours looking at puddles, trying to figure out how these bugs got into that puddle. And in my mind, I was figuring out an elaborate system of the sewers flooding too much and bringing bugs in or something. But now I've learned that a lot of these aquatic invertebrates that we're seeing actually are larval stages of terrestrial invertebrates. So a dragonfly or a mayfly or stoneflies, all examples of animals that are growing up in the water. They metamorphose. They change, a lot like a tadpole to a frog, or sometimes kind of like a caterpillar to a butterfly. They're changing from a larval individual into an adult individual, and that process there, that you have that transition from being aquatic to terrestrial. And that's how you get these terrestrial animals then fly around to different water sources, lay their eggs, and that's how you end up with bugs and puddles. But it's a neat system, seeing how they kind of grow up as larvae and then turn into adults.
That is very cool. And kind of an analogy to that, I have a pretty vivid memory of the first time we went to New Mexico, you staring into a puddle and looking at some stuff wiggling around in there. So you haven't grown out of your habit of doing that like a aquatic invertebrate might when it turns into an adult. So yeah, you haven't grown up yet.
Well, I think that curiosity is important, always trying. That's what makes us biologists or scientists. We are always curious, and we're looking and trying to figure out what's going on. That was a neat system. That was at the top of a rock system at a high elevation, an area that there had no business being aquatic invertebrates up there. And
Sure.
And there were a lot of mosquito larvae, but also some little fairy shrimp, and thinking about that process of how they're flying around, they're looking for water. And that's also a good example of how in those systems where they're drying out really often, that area could be dry for a few years before it gets a good rainfall again. And those eggs can sustain themselves in those dry environments. And then as soon as it gets a rainfall, they can release those larvae, complete their life cycle. It's just really cool adaptation. So that curiosity is always there for sure.
Yeah, definitely. So you talked a little bit about the value of some of these aquatic invertebrates, as sort of working as the cleanup crew, helping to break down that organic matter and that sort of thing. What else are they good for? Why should we care about them?
Sure. A couple other big things they do. One of them is that they're really important in food webs and aquatic systems. And so if we think about fish, a lot of times we're thinking about the fish in the system as kind of what we're managing for, but those little fish, larval fish, need to have something to feed on, and a lot of times it's invertebrates that they're feeding on. So entire food webs, if you take out invertebrates, the food web's going to collapse. You're not going to be able to have fish if you don't have these invertebrates in the system. So understanding the importance of them feeding other organisms is really beneficial. It can also be indirect feeding. So they might make some resources, break down a leaf, for example, into little pieces that then can be utilized by another organism, where it might be too big if it was the whole leaf they were trying to consume, but a small piece of that they might be able to. So some benefits there, breaking down that organic material. They can help sometimes with algae control. This is especially common in like little small backyard ponds. So it'd be hard to do in a 1 acre pond or something really big. But if you think about that aquarium example we talked about, where snails or some sort of grazer is walking back and forth cleaning off the algae, you can see that happen in smaller systems as well. So they can help to keep control of algae a little bit. One of the really good ways that we use them as scientists is to look at water quality. And so it's a little bit antiquated at this point, but there's this idea that you can go look at invertebrates, and it's called the EPT index, Ephemeroptera, Plecoptera, and Trichoptera index. Go look at the ratios of different invertebrates, and it'll tell you the relative health of a river or stream based on their abundance. And so if we're doing that, if we're going out to our pond and we don't see any invertebrates, that might be an indication that there's something going on, something we'd want to look at.
If we don't have enough invertebrates in our pond, should we stock them?
Generally, no. They're going to establish themselves, but I think the opposite of that is what happens more often, is that we get so concerned about there being any growth of any sort that we go kill everything, right? And we've talked about the importance of that food web and the benefits that these invertebrates have. And so, you might not go stock them, but you could actively decide not to kill them all, not to add a chemical or do things that are going to, hurt the invertebrates themselves.
So is that something that, somebody could actually buy an aquatic insecticide to kill off the bugs in their pond?
Yeah, you'd see that more likely with snails, for example, where they make products that can do that. A lot of times it's unintended consequences. So you might be spreading an insecticide around the edge of your pond, for example, and that can get into the water itself. These aquatic invertebrates are even more susceptible to a lot of those chemicals than the terrestrial counterparts. They're absorbing a lot of the way they breathe can be through gills or through their skin, and so they can just absorb a lot of the chemicals a lot quicker. So smaller doses can be really detrimental to them, and understanding the implications could be a problem. There are times, like if you're overrun with certain types of snails, the only way to fix that would be either to drain the pond or add some chemicals. So there might be times to do that. We just want to make sure that we have a good thought-out plan. We've talked to a professional about it before we go and do something like that.
If we did have a bunch of snails, is there anything that we could do to that pond that we might get some secondary benefits from?
Yeah. So, one of the big things is stocking bigger fish, establishing bigger fish, and establishing the right types of fish. It would depend on the type of snails, but a lot of fish will eat the snails. So there's benefits there. They make traps for snails that can collect really large numbers and get them out of the system that way. So there are definitely some benefits there and ways that we can use those animals to benefit the pond. Kind of would depend on the system on what we're going to do.
Cool. So you mentioned that we can use that EPT index. Is that something I ought to be doing in my own pond, or should I monitor my invert numbers?
I don't know that you need to monitor them. That's kind of something maybe the professionals would do, kind of the next level up. But thinking about maybe not getting that select, but go watch your pond. We talk about that a lot, right? Go out to your pond, go out to your stream and see what you see. A lot of these invertebrates you might not see. They might not be active all the time, but get a net, collect some leaves and see if there's, something crawling around in there. It'd be a good indication to kind of look at your pond and see what kind of activity you might have.
Sure. That kind of thing's always fun. When I was a kid, I didn't stare into too many puddles like you did, but I did do a lot of net throwing and that sort of thing. And we had a pond on our place when I was growing up, and I always enjoyed all the different things that I saw. One time I was out there, I think, dragging a net for a science project, and I ended up catching a whole bunch of I probably won't say the right stage, but they were like larval mud puppies out there. And so I just kept, every time I'd throw the net out there, I'd drag it back in, and it'd be full of these little like 2-inch long mud puppies that had great big gills coming off of them. That was pretty neat to see.
Mud puppies are an aquatic amphibian, and so they're almost prehistoric looking. They don't really look like they should belong, but they have those big gills. They're really susceptible to water quality too. So if you were seeing those in your pond, you probably had a pretty healthy pond.
So Joe, you mentioned that a lot of these aquatic invertebrates are as adults insects that might be able to fly, and so they can get to ponds that way. Where that same area where I was seeing the mud puppies, sometimes I'd be walking around out in the pasture and there'd be dead bluegill or dead green sunfish just out in the middle of the pasture, and I didn't really understand how that happened. And one day I was out in the pasture during a great big rainstorm, and there was sheet water throughout the whole pasture, and I could see these little bluegill and green sunfish swimming across the pasture. And so that makes me think about another way that stuff can get into aquatic environments in different places.
Yeah, those flashy events where you get a rainfall, the water comes up so much. You might have an entire field that's covered in an inch or two of water. It might only be like that for 10, 15 minutes, but those fish take advantage of that. Those flooded habitats a lot of times have a lot of invertebrates or energy that they can utilize. So they might go out there looking for a place to eat or a place to get some mating. It might be a mating habitat. So different things that they can do in those environments, and it's really cool. Those high flow events can also cause something called invertebrate drift. And there's a couple types of invertebrate drift, passive and active. So when we're thinking about a high flow event, pushing those invertebrates that may be hanging out on a log or on the substrate or something. You get a big flood come through, and it just pushes them downstream. There's also, a kind of an active event where the bugs decide to do this, and we see this a lot in streams and rivers. During dusk and dawn, if you go out and set a net out there, a lot of bugs just kind of decide that, hey, they're tired of living where they're living, and they just jump up into that current, and they get pushed downstream. And so that movement, that invertebrate drift, the numbers are 10 or 20-fold what you would normally see. Huge spikes in the amount of invertebrates drifting downstream. That can provide a lot of opportunities for fish to feed. It also moves those fish, those invertebrate populations downstream. So that terrestrial movement again, repopulating those areas where the adult insects emerge and go disperse their eggs, really important for making sure invertebrates stay everywhere in the system.
Very cool. And that, I guess that kind of fits too with when fish bite the best, especially in flowing systems. I grew up fishing the Neosho River by low water dams, and we'd have high flow events. And if that high flow event was due to a rainfall, man, that was some of the best fishing that we ever had. The fish were going to bite like crazy, and then of course they always bit pretty well in the evening or early morning too. So that kind of makes sense.
If you can go out during a high flow event at sun's either coming up or going down, and you look at the bellies of those fish, they're just packed full. So that's a good time to catch them actively feeding for sure. A lot of times they might be feeding on things that would be found in the system, like crayfish can be commonly found in these systems, and they might respond to these high flow events, or they might move into some of those flooded habitats like we talked about. And that might be an opportunity for fish to catch them a little bit more vulnerable area. But so all types of invertebrates that they're feeding on at those times.
Interesting. Well, you brought crayfish up again. As we talked a little bit about maybe it's not a good idea to stock invertebrates. What about crayfish? I know that's one that some folks stock sometimes. Should we stock crayfish in our ponds?
Sure. It can be an option, right? But it's generally not something I recommend. If you are thinking about doing it, you'd need somewhere around 50 to 100 pounds of crayfish per acre. And so, it gets pretty pricey pretty quickly. And we're hoping that those crayfish establish and reproduce and provide food long term. If you just put them in and they get eaten, remember we're getting about 10% of that out of the fish, right? And that's 10% growth. And so quite a bit of money to get 5 or 10 pounds of total growth. They may help jumpstart a pond, but the big issue is if you don't have the right fish structure, meaning primarily larger fish that can eat a big 3, 4, 5-inch crayfish, then the crayfish are going to start to reproduce, and you're going to start to have a lot of offspring that then can compete with things like the small largemouth bass or more so the small bluegill. And the crayfish can actively feed on them. They can feed on their eggs, and you can start to see changes in the fish population where we want to have that strong bluegill class to feed our bass. The numbers of bluegill might start to dwindle. So while we think we're adding an additional food source to our pond, that can happen. But what I see more often is that we get a little bit of a push and influence from adding those crayfish initially. But long term, they cause more detrimental impacts to the fish population than if we just did things like, reestablish some bluegill habitat or figure out how to get the bluegill to maybe get to a little bit bigger size where they can feed our bass. And so it's not necessarily not an option, but you'd want to make sure that your pond's set up for it and you've really thought through it before you add them in. It's not just hey, this is a good food source, let's throw it in there and it's going to make everything better. A lot of times it's the exact opposite that happens.
Interesting. Dr. Clausen, I remember him talking about having ponds where he sort of used crayfish as the food base for channel cat.
Yeah.
And he would grow really big channel cat, and sometimes he'd draw the water down and catch the crayfish, but maybe those ponds were just catfish ponds. He wasn't trying to grow bluegill and bass in them.
Yeah, a large amount of channel catfish especially, which is what Dr. Clausen used to raise a lot, they love invertebrates. About 80% of their diet is invertebrates or detritus, so it's not as fish heavy. And I guess that is a good a good disclaimer there. When I'm talking about that, a lot of times when people are talking about stocking crayfish, to me, it's in a primarily bass fishery pond, right? So there might be examples where if you have channel catfish in a pond and you want to make them bigger, adding some crayfish may be beneficial there. And because their diet is primarily invertebrates, but understanding the influence they're going to have on the bluegill, on the bass, on the rest of the fish population is important. Doesn't mean it's not something that can't be done. It certainly can be done. You just need to make sure you have a good plan. You've thought through it. You don't want to just go buy a 10-pound bag of crayfish and throw them in because you saw them at the farm store.
Yeah, no, that makes sense. Well, Joe, what are the main takeaways that you want to make sure people come away from this episode about aquatic invertebrates with?
Yeah, I think invertebrates are one of those groups that most of us kind of just walk by and don't think about them, but they're really important. We talked about the functional feeding groups, how they kind of break down some of the detritus, the organic matter, and make that available to other organisms in the pond itself. And so understanding those and their role in the food web is really important. So if we're not doing things, at least in the back of our mind, thinking about the invertebrates and the effects that they might have on our pond, our entire food web could collapse. So not always the most glorious thing, but make sure you're kind of thinking about them and including things that could benefit invertebrates in your pond management plan.
Well, that's awesome. Well, folks, just remember, you heard it here. Remember the bugs when you're thinking about your pond.
That's right, or looking in a puddle next time.
All right, thanks everybody for listening. Please leave us a review if you haven't. That's important for our show reaching other people and the content that we produce getting out. Get out there, enjoy your pond, enjoy the wildlife. Dove season's about to start, so we've got that coming up, and we'll look forward to talking to you next time.
Fins, Fur, and Feathers is hosted by K-State Research and Extension and is a part of the Natural Resources University Podcast Network.
The network and this podcast are supported by the Renewable Resources Extension Act.